All right, let's dive into one of the most critical skills for anyone touching data. I'm talking about SQL joins. And trust me, by the end of this, you'll see why we call it your data superpower. So, picture this. You've got data all over the place. Maybe you have a table for your customers, another one for their orders, and a third one for product details. It's all connected, you know it is, but it's living in separate houses. So the big question is, how do you bring it all together to tell a single coherent story? And the answer, my friends, is the join. Honestly, the easiest way to wrap your head around it is to think of it as just connecting the dots. You have one list of things and another related list of things. The join is what weaves them together using a common piece of information to create one big, useful picture. It's that simple. Okay, so here's our game plan. We're going to start with the absolute foundation, the inner join. Then we'll get a little more adventurous and explore outer joins for when things don't quite match up. After that, we'll look at a couple of cool special cases, the self and non-equi joins. And we'll wrap it all up by making sure you're ready to use your new superpower. First up, let's talk about the bedrock of the whole operation, the inner join. I'm not kidding, this is the one you're going to use most often. It's all about finding those perfect one-to-one matches between your data sets. Need an analogy? Think about LinkedIn. You have millions of user profiles, and you have millions of job postings. An inner join is what you'd use to see only the people who currently have a job listed on their profile. If a person's profile is there but has no job posting, you won't see them. If a job posting exists but no person is linked to it, you won't see that either. Only the perfect pairs make the cut. And that's the absolute key takeaway right there. An inner join looks at two tables and only gives you back the rows where the values you're joining on exist in both tables. It's exclusive, it's picky, it only cares about the data that has a clear, confirmed connection. No match? You're out. And this isn't just theory. This is the real world. A massive 60%, think about that, of all the joins that backend engineers write are inner joins. Why? Because most of the time, that's what the business needs to know. Which customers bought which products? Which employees are in which departments? Those are pure inner join questions. So if you master this one, you're already most of the way there. But what about all the data that doesn't match? What if you need to find the gaps, the missing pieces? An inner join just hides all of that from you. To see the whole story, we have to go beyond those perfect matches and enter the world of outer joins. Let's start with the left join. The name tells you pretty much everything you need to know. It takes the first table you name in your query, the left one, and says, okay, I'm keeping everything from this table no matter what. Then it looks over to the right table to find matches. If it finds one, awesome, it pulls that data in. If it doesn't, it just puts in a null, which is just a placeholder for no data found here. And this is the perfect example. Let's say you need a list of every single student enrolled in your school. You don't care if they've taken a test yet or not. You do a left join from your students table to your marks table. You'll get a list of every student, and for the new ones who don't have any grades yet, the marks column will just show up as null. Simple as that. Now, what about the right join? Don't overthink it. It's the exact same idea, just the other way around. It keeps everything from the right table and fills in any missing matches from the left with nulls. It's a perfect mirror image. Once you get the left join, you have already understood the right join. So that leads to a pretty obvious question, right? What if you want to see everything? All the records from the left table, whether they have a match or not, and all the records from the right table, whether they have a match or not. Well, for that, you have the full outer join. It's the whole shebang. Now, while the full outer join is super powerful, it's kind of a special tool. It's fantastic for things like data audits or comparing two systems during a migration where you need to see every single discrepancy. But here's a pro tip. For most of your day-to-day work, just stick with the left join. It's usually easier to read, easier to reason about, and it answers most of the questions you'll have. All right, you've got the essentials down. Now we're heading into the advanced class. Let's look at a couple of special joins that solve some really interesting and surprisingly common problems. We're talking self-joins and non-equi joins. A self-join? I know, it sounds weird, right? Joining a table to itself? But think about it. What if you have a table of employees? And in that table, each employee has a column for their manager's ID. Well, that manager is also an employee in the very same table. A self-join is the elegant solution for untangling these kinds of hierarchical relationships. And here's the logic, broken down into 3 easy steps. 1. You start with that single employees table. 2. In your query, you pretend you have 2 copies of it. giving them different nicknames or aliases, like E for the employee and M for the manager. And 3, you just join them. You connect the manager ID from the E copy to the employee ID on the M copy. Boom, you've just linked every employee to their boss. Okay, one more special case, the non-equal join. Every other join we've talked about relies on an equal sign, employee ID equals manager ID. But what if your logic isn't about equality? A non-equal join lets you use other conditions like greater than, less than, or between. This is an absolute game changer for things like matching an employee's salary to a salary grade table.
Phew! We have covered a ton of ground. You now have the core concepts to connect just about any data you can imagine. So let's wrap this up and really cement your new superpower with a few key takeaways for writing clean and powerful queries.
Okay, lean in because this is a big one. Please, please always use the modern ANSI JOIN syntax. Why? Because it is so much cleaner and easier to read. It separates what you're joining on from what you're filtering on, which will save you and your teammates so many headaches. It's the global standard for a reason. And here it is, the cheat sheet you can screenshot. Just burn these shortcuts into your brain. Inner join, that's for matched only. Left join, all from the left. Self join, that's when you have the same table, different roles. If you can remember these, you will always grab the right tool for the job. And if for 1 second you doubt how important this all is, look at this number. A mind-blowing 80% of the queries running in the back end of big enterprise apps have at least one join in them. This isn't just some neat trick. It is the absolute engine of modern data retrieval.
So yeah, this skill is foundational. And now, it's yours. We'll leave you with this final thought. You now hold the keys. You have the superpower to connect any dots you want. So the question isn't how anymore. It's what amazing stories, what hidden insights, what game-changing answers are you going to go out and uncover?